Welcome to the January podcast episode of Radiology AI. My name is Dania Daye, and I'm the Associate Editor for Social Media for Radiology AI. And today, my co-host Paul Yee and I are very excited to bring a new episode of the Radiology AI podcast series, where we will be interviewing Dr. Kathy Andriole and Dr. Walter Wiggins on the topic of AI education in radiology. This is based on the recent article that was published in Radiology AI that was entitled Preparing Radiologists to Lead in the Era of Artificial Intelligence, Designing and Implementing a Focused Data Science Pathway for Senior Radiology Residents. Dr. Kathy Andriole is Associate Professor of Radiology at Harvard Medical School and at Brigham and Women's Hospital. She is also Director of Research Strategy and Operations at the MGH and BWH Center for Clinical Data Science, the CCDS. Dr. Andriole studied biomedical engineering and electrical engineering and medicine at Duke University and Yale University, respectively, and did her postdoctoral fellowship both at UCLA and UCSF. While at UCSF, Dr. Andriole was instrumental in designing, building, and implementing PACS before it became commercial. Her research has involved technical as well as clinically relevant developments in medical informatics, PACS, digital radiography, image processing and analysis, business analytics, and machine learning. Dr. Andriole has served in multiple leadership roles in SIM, RSNA, and ACR, where she is currently Senior Scientist for Education for the ACR Data Science Institute. She is also Associate Editor for the Radiology AI Journal and the Journal of Medical Imaging. Dr. Andriole has been elected a member of the Academy of Harvard Medical School and inducted into the SIM College of Fellows. Dr. Walter Wiggins is Assistant Professor of Radiology and Staff Neuroradiologist at Duke University Department of Radiology. He received his MD PhD degree from Wake Forest University, which was followed by radiology residency at Brigham and Women's Hospital and a fellowship in neuroradiology at Duke. During residency, in partnership with Dr. Kathy Andriole, he co-founded the BWH CCDS Data Science Pathway, one of the first of its kind for a direct pathway to learning data science for radiology residents. His research interests have focused on applications of AI in neuroradiology, and he is currently clinical director of the Duke Center for Artificial Intelligence in Radiology, or DARE. We are very, very excited to have you both with us today, Kathy and Walter. I will turn it over to Paul to start the discussion. Paul?
Dania, thanks so much for the introduction, and a special thank you to Kathy and Walter for joining us on the podcast. We're really excited to have you. So both of you have been involved in imaging informatics and AI for several years, but from different viewpoints and in different capacities. Kathy is a PhD informaticist and really one of the leaders in the field, bringing in technologies like PACS and now with AI in 2020. And Walter is an MD radiologist who's earlier on in his career but really been at the forefront of a lot of the technologies and as well as the education, as we'll discuss. Can each of you share with us how you got involved with AI and to the areas of work that you're in today? Maybe we can start with Kathy.
Sure. So my PhD work, I studied classical machine learning, image processing and analysis. And at the time, we didn't have the computing infrastructures to really make this clinically relevant. And as Dr. Daye mentioned, I went out to California, UCSF in particular, to think about digital imaging and got involved in building PACS. Have been involved in medical imaging informatics for a number of years and really now have come full circle by joining the Center for Clinical Data Science and back doing machine learning, where we really can implement these things clinically and have them impact clinical care is my hope. But it's really been a cycle of making radiology digital in the way that we acquire and consume it, that enabled us to have access to all this treasure trove of digital data that we can now use in artificial intelligence.
Walter?
Yeah, so my PhD work focused more on electrophysiology and computational neuroscience, modeling small neural networks of really just a handful of neurons in the rodent brain in a couple of models of animal seizure and alcohol withdrawal that we were studying at the time. And so I was initially exposed by that path. I'd also been doing some computer programming for a number of years. And so when time came for me to go to residency and I found myself at Brigham and Women's Hospital, it really coincided with TensorFlow being open sourced, kind of at the beginning of the rise of computer vision with convolutional neural networks. And so I learned of it pretty early on in my residency and started teaching myself Python on the side because I had discovered that that was really the lingua franca, so to speak, of machine learning and convolutional neural networks. So it was with that interest and spark that I kind of started my residency and did some of this in my spare time. But it really wasn't until Kathy and others formed the Center for Clinical Data Science that I realized there was a potential for getting involved more deeply in AI research at Brigham and Mass General. And so that was really the timing just coincided perfectly with me formulating plans for my third year with my co-residents, Travis Caton and Kirti Magudia, formulating plans for their third years. And we all kind of, through separate paths, arrived to the same conclusion that this was a place we wanted to spend a lot of our time. This is work we thought was going to be very important in our careers. And we wanted to emerge from our residency programs with the skills to really one day become leaders in the field.
Oh, thanks for sharing. It's really interesting to hear about your different paths. And ultimately, speaking of timing, how you cross paths over at Brigham and Women's Hospital and Harvard Medical School, and in particular with the CCDS data science pathway. Can you tell us the story behind the program and how it got started?
Sure. As Walter mentioned, he and Travis and Kirti came to me individually, actually, with a desire to do something in their fourth year. And our program at the Brigham actually is fairly flexible and allows people to focus on a variety of things. We already had a global health pathway, an education pathway, and other things, but we didn't have anything around data science. And I had been teaching the residents a little bit about machine learning, just at a very high level, as well as imaging informatics, to give them that content that I really feel that they need as outgoing radiologists. And we tried a pilot, and I was lucky to have Walter and Travis and Kirti be the first folks to try this pathway. And this was done obviously with the approval of our leadership and the program director and so on. And it was so successful that it was made an official pathway that residents can do. And we've subsequently had 2 classes after Walter's class to participate in this pathway. And I think that's just how, they really knocked on doors and came to me with this desire to do this. And I said, great, let's do it. And we got approval, and that was that.
Brigham had really formed a tradition in recent years of residents sort of mapping out their own pathways for the fourth year of residency. And we saw that there was an informatics fellowship available, but that was really more geared towards clinical effectiveness and closely tied in with programs along those lines at the School of Public Health, the Harvard Chan School of Public Health. And we really felt the need for something that was more data science intensive, more geared towards AI and machine learning. And so that was our reasoning for developing yet another pathway for the fourth year.
Tell us, for the listeners who may not have read the paper or not know as much about the data science pathway, what is the pathway comprised of? What are the different parts of it?
Sure. I think for Walter, for the first year, again, we were developing as we were going. And today there's more formal curriculum that's been developed that includes not only a didactic component, but hands-on exercises, additional materials, where you're learning, basic topics now, walking you through how to approach a machine learning problem, including things like data wrangling, pixel wrangling, and so on, and using, collabs so that even if you're not an experienced Python programmer, you can step through some of these things. There's also an experiential component and a major research project, which all of the all of the residents do, and we try to match it to something they're very interested in. And Walter was interested in neuro, as was Travis, and they focused around some of the neuro projects that were already ongoing since they were the first. And in subsequent years, we've had folks do things in abdominal imaging as well as neuro and MSK based on their particular areas of interest. So it was really a didactic component or educational component, an experiential component, and a research component. And they were really embedded in the center, which if you looked at the way the center was set up, we had machine learning scientists, we had software engineers, and clinical people. Every project that we do had a clinical champion involved. And they were all co-located in sort of this big open space, which was the center. And I think that's how people kind of got involved. And we had some nice activities of people learning about each other's strengths and so on. And I even saw our residents teaching our machine learning scientists some of the clinical nuances that really informed how to work with the models, and learning where the failures were and why, actually from our residents who had the clinical acumen that we did not, and that our machine learning scientists and software engineers did not. So I think it was a program that was set up that is now more formal in terms of its curriculum, with recorded lectures and asynchronous learning and so forth. But I think it was a really great experience in having them get to know. I see this as a team sport, and really having them get to know that this involves other people and everyone contributes to the solution. And that's what we did in the first year, and have subsequently improved it since then.
And I would add to that really the benefit of the way that this program was set up, or is set up, was that you have the foundational component that consists of the didactic lectures and the discussions of different papers in machine learning to really understand the foundational concepts of how we go about doing this kind of research. But that the experiential component that embedded research that we were doing at the center was really where the rubber met the road, but that it could be tailored to an individual's needs. So Travis didn't spend as much time doing research as I did, because he had to fulfill certain requirements and do certain rotations in anticipation of doing a more interventional heavy fellowship, whereas I had a little more time and a little more flexibility in my fourth year. And I think that flexibility was really important, and really helped us all to get kind of what we needed out of the experience.
So an initiative like the data science pathway seems to really emphasize and exemplify interdisciplinary collaboration, for example, between physicians and engineers. And Kathy, I thought it was really interesting to hear about the setup of CCDS. I've had the opportunity to take a tour of the CCDS, and it's really cool, the setup. Just as you said, it's kind of like a startup where you've got engineers working alongside with physicians and other data scientists. But I imagine there might have been some challenges because people bring different experiences, maybe different ways of thinking. So could you talk about what were some of the challenges and benefits of bringing together groups of people with different sets of training and expertise in this pathway?
Yeah, no, definitely. Walter came in with a PhD, as did Curdy, but Walter had done some work in computational medicine. But Travis had no programming. Kirti had very little. Our resident this year has had very little as well. The makeup of the center itself had folks who didn't necessarily speak medical language, and not even really knowing what different medical imaging views were. We had some machine learning scientists, one who came from the military, others who came from industry and hadn't been working in the healthcare arena. So there's always that issue of communication and so on. And so as I move forward with formalizing some of the didactics, I had to sort of do a balance and weigh, what was important in terms of, was it most important to teach the programming aspect? And I went and erred on the side of being sort of more allowing more general backgrounds to be able to grasp what was going on and to really understand what was going on, rather than the mechanics, which Walter got into quite heavily, and it's helped him significantly in now his future role. But I think I had to gear some of the didactics to people with a huge variety of backgrounds in terms of the residents, because I didn't want to say you need to have this background or that background in order to do the pathway. And I think those were some of the challenges. But language, I think, was something that not everyone understood. And we could see something failing in a model on a particular case, which was a mystery to the non-medically educated, whereas immediately our residents could say, well, that's because that's a confounder or whatever, and here's what you need to think about. And I think that just speaks to why we need to have this be multidisciplinary.
Yeah, and to piggyback on that a little bit, I think most of my educational efforts now have geared towards trying to devise ways that people can either be exposed to the code and how the models are trained and how the experiments are run, but also allowing the code to be hidden or people to be able to run through an experiment without having to understand what exactly the code structure is and all of the details of what's running underneath the hood, but getting just deep enough that they can start to understand a little bit better about what it means to have to split up your data set into training, validation, and test data sets. The importance of holding out data in order to not expose it to the model during the training process, to be able to test it and determine how robust the model is to data that it hasn't seen before. And I think having that understanding and having gone through the process of training these models myself really helps me to have better conversations with the data scientists that I work with now in terms of troubleshooting when model training goes wrong or when performance isn't quite what we need, and being able to go through that failure analysis with them and understand what's happening during the training process allows us to have a better collaboration. And I can then in turn give them more information about what's going on the clinical side that might be contributing to the problem that we're facing.
I'm sure that a lot of our listeners might be interested in starting a pathway similar to yours at their training programs or even within their radiology practices. What advice do you have for radiologists who might want to start a similar program at either their program or even their own practice?
I think we're having a lot of radiologists get involved, and I think there are so many online resources that one can take advantage of. Not all of them are geared to medical imaging or even medicine. And I think there's a particular benefit to being able to learn from that domain, from that context. Because I think there are differences in some of the things that you do. I mean, we see some machine learning scientists who, when they do start working with medical data, are kind of flummoxed because they haven't come across some of the issues and very basic things like what Walter's talking about, cohort design, how incredibly basic that, but important that is, and how many people get that wrong when they start off. But I think, if you have an interest in learning this, there are some things you can learn to get you to a certain level. And there are also things that walk you through hands-on wise that can help you to learn, as Walter said, to be able to speak with folks who are maybe more on the machine learning side. So I think it's something that you should get involved in, but I don't want people to lose touch with sort of the understanding of the fundamentals. I think people may start and jump into the programming itself maybe too soon and not really get a good grasp of what the fundamentals are and how changing different parameters may change the behavior of the model and so on and so forth, and being able to analyze what's going on, or even just to learn to be able to analyze what's happening from an industry product, or assess the literature, read a paper and understand it. But I think if you have excitement and interest, go for it is my suggestion. And then if you can partner with some someone who maybe is more on the machine learning side. We've seen this through a lot of the RSNA challenges that have been put forward by the meeting, during the meeting, and so forth. We've seen clinical people partner with non-clinical people to create a team to participate in the challenge, and we all learn from that. Even those of us who are putting on these challenges learn by what these folks are doing. So, I would say I would take someone who's enthusiastic and wants to learn about it and put a program together. Start small, maybe start in an area that you're very, very interested in, your particular area of clinical expertise, and go for it.
And to add to that, I can actually speak from recent experience. I've had people reach out to us already reach out to me already since publication of the article in Radiology AI and ask, what advice do you have for starting up a program? This is what we're thinking of doing. And the advice that I give is to start small, to start with the materials available attached as supplemental materials in the article itself, which are available to the journal website and free to RSNA members. And if you can't get access to those somehow, if you're not an RSNA member, feel free to reach out to me and I'll be happy to send along the resources that we provided. We gave them an outline for our curriculum. We gave them links to the kinds of resources that Kathy is talking about, where they can go and look at courses that other people have already built that are very good and have been used and reviewed by us, and really take that as the foundation to learn those basic principles. And then from there, you can build on trying to get people more engaged in programming or more engaged in higher level or more detailed discussions of the mechanics of machine learning and the methods of machine learning as they are ready. But I think the best advice is really to kind of gauge your audience, meet people where they're at. Don't try to go too hard, too fast, and start small and progress from there.
Shifting gears slightly, there's been a lot of discussion about the potential impact of AI on the clinical practice of radiology, whether in improved efficiencies or improved accuracy for our clinical work. But as we've seen with the data science pathway, and Walter, with people come to you for advice, there's also a lot of implications and interest for education of residents and fellows, and even medical students or students at the undergraduate level. Do you have any thoughts about how AI might impact education, either in radiology residency or fellowship, or in medical school or undergraduate in 2021 and beyond?
Definitely. So as a sort of an outshoot of the pathway, and because Walter and Travis and Kirti did so well in that first year and generated such enthusiasm among their colleagues in residency, I was asked to put a series of lectures together, which I did, that included some hands-on that I give to the residents. I also do a monthly with the Harvard medical students who rotate through on the Brigham side. It's not hitting everyone, but there is definitely an interest in getting education at this level, and even in the undergraduate level. And I think, many of our specialty organizations, the RSNA in particular, as well as the ACR and SIM, the Society for Imaging Informatics in Medicine, are about education and putting forth a number of courses. Many of them were oversubscribed at the RSNA the first year that we put them out, and the same at SIM and so forth. So I think there are more and more educational opportunities, but I think our residents, this is kind of a switch now. When you think about a resident, a student, a resident, a fellow, and faculty, on the clinical side, you can kind of gauge the clinical expertise. Whereas when you think about educating people about machine learning, you may have residents who are maybe even more excited and maybe a little more advanced, or fellows, than perhaps the faculty, though the faculty still want to learn. So I think the whole profession is doing a really good job in getting out front and trying to provide educational activities for everyone at each level, though they may be at very different clinical levels, that we need to be able to address this and start early on, as early as medical students, and certainly undergraduate programs are cropping up in data science and being very, very popular. So I think this is just going to grow, and I'm excited about that.
I think radiology AI education more broadly, apart from the more focused data science pathway that we've developed and similar pathways that other programs might develop, is probably going to go the way of physics and the role that physics education plays in radiology training. Maybe not on the same scale, but the reality is we have to learn the fundamental principles of how images are generated in order to be able to interpret images adequately. We need to understand the artifacts that are generated. We need to understand the types of problems you run into when trying to generate an image. And I think the same is going to go for using radiology AI tools in practice, that you're going to need to have a good understanding of how those tools work and where those tools can go wrong in order to use them effectively in your practice. So that's really the way that I see radiology education going. But right now, where we're at is kind of in the early phases where people are starting to think about these things. I just gave a board review lecture to our residents at Duke who are getting ready to take the core exam, and looking over the non-interpretive skills document for this year's core exam yesterday, I discovered that artificial intelligence is a single line in a 44-page document that covers a lot of other information. And so, you know, I think that role is going to grow. It may be something that we get tested on boards eventually, but I think the role of educating people about this technology and how it works and how it can go wrong is going to be very important going forward.
Yeah, and if I could just add, you know, this is a similar track for imaging informatics in general. You know, I instituted an imaging informatics session for a series of lectures for the residents. And, you know, much like the medical physics, you think I need to bring pizza and beer for people to be excited about this. And you get, you know, few people who self-select and so on. And those kinds of questions around imaging informatics are now appearing on the boards. You know, there's so much clinical that everyone has to learn, but eventually these will be on the boards more and more. But I just think there's a tremendous interest and excitement about learning about these things, and because it's going to impact clinically how you all work from a standpoint going today and forward. So I think I agree with Walter. It's something that's going to slowly gear up and eventually be something that people don't think about as a specialty kind of topic that they need to learn.
It's definitely an exciting time to be in radiology and see AI really coming to its own. As we enter the last few minutes of our time, I'd like to ask you both a question. What are you most excited about for the next decade in radiology AI or informatics in general?
Well, I'm very excited to see these tools implemented clinically and have us understand the impact of them, and to learn more about these tools, because as we implement them clinically, we learn more. And as we've created models using data, started with the low-hanging fruit. You know, everyone had a bone age detector, everyone has a lung nodule detector and stroke and so on and so forth. Some are better than others, and there are reasons why. And, you know, we are starting to understand a lot about a data cohort design and technical drift of algorithms and so on, as you start to think about how do I put this in the clinical arena. And so I'm very excited to see what happens there. I do have a fear that clinicians will just blindly accept these tools and not be vigilant to see, because they can go wrong. And that's why I think that education is so very important, that we understand enough about how these models can fail and come up with an answer that may be nonsensical or just completely out and out wrong, by understanding more about the technologies. But I'm very excited about seeing things clinically implemented. And I'm also like to see these technologies being used more in underserved areas. I really hope that we'll be able to provide the high quality of care that we all have at our academic medical centers, provided to people worldwide in areas where there aren't the types of resources that we have. So those are my hopes for using these technologies, both AI and informatics.
Yeah, and I think I'll preface my answer to the question with the reality that adoption of these technologies has been a lot slower in clinical practice than the hype and the number of startups that we see at RSNA every year might otherwise pretend. And so, I think that what I'm most excited about is being in the trenches and getting involved both at an institutional level and at an organizational level with the ACR and RSNA and SIM in figuring out the answers to the problems that Kathy was talking about, in figuring out how we set up systems for automated monitoring of algorithm performance to catch algorithms when the performance starts to degrade. How do we set up informatics workflows to make that happen? What kind of monitoring needs to be done? What metrics are we using to determine degradation in algorithm performance? And how can we automate this process in some way, are a lot of really interesting questions. And I think another thing that I'm excited about is the role that natural language processing, or NLP, might play in helping us sort of close that loop on feedback on algorithm performance by automated extraction of labels from radiology reports and comparing that to the AI model's predictions to see whether or not the radiologist agreed or disagreed with the model's prediction. So those are some of the things that I think are really exciting, and some of the problems that I hope get solved in the next decade as we see increasing adoption of clinical AI technology.
Well, thank you both for taking the time to talk with us and our listeners about AI in education, the clinical data science pathway, and what you're excited about over the next decade. So thank you again, and I'll give it back to Dania.
Thank you, Paul. And thank you, Dr. Andriola and Dr. Wiggins, for such a great discussion. And thank you for sharing with us your experience designing and implementing a data science training pathway for radiology residents. What a great program to educate the next generation of residents who are interested in AI. I am very sure that many of our listeners will be benefiting from your experience as more of these programs are implemented around the country. To our listeners, thank you for tuning in to our January podcast episode. Don't forget to rate, review, and subscribe to our Radiology AI podcast series on any of iTunes, Google Podcasts, or Spotify. And please stay tuned for our next episode.